working with atomic symbols. When you are given a symbol, for example, sodium, 11 is its atomic number, which is the number of protons, neutrons, and electrons, and 23 is a typical mass number. This is the protons plus neutrons. This represents protons. The difference here tells you that there would be 12 neutrons in this sodium atom. Now, if you'll notice, the atomic number, or the atomic weight for sodium is 22.989, and typically the most common mass number is pretty close to this atomic weight. But you cannot directly use these numbers to get a mass number, because there are different forms of sodium. You could have sodium 22 or maybe even sodium 24, but they are not very common and may not be naturally occurring. But this is the average of the naturally occurring isotopes. So this is the typical way that you would write. You have your mass number at the top left and the atomic number at the bottom left. Sometimes you will see the mass number written beside it. This way you don't have to use superscripts and subscripts. But at any rate, if you have a table like you have here and you need to fill in some of the pieces, for example, here's 3,2 helium. Well, helium has to have an atomic number of 2. It has to have 2 protons. If it is neutral, and all of the atoms here are neutral, the number of electrons will equal the number of protons. So all of these 3, atomic number, protons, electrons, will be equal. I have the protons in this column because protons plus neutrons will equal the mass number. So if we have a mass number of 3, which is given, then we know that we have 1 neutron. The next one's lithium, and it tells you that the mass number is 7. Well, to fill any of this out, you need to go to the periodic chart, and you will see that lithium is atomic number 3. So it has 3 protons, and if it's neutral, it has 3 electrons. And 3 plus some number is equal to 7, so the lithium has 4 neutrons. And the symbol for lithium would be 7,4. Here's uranium. If you look uranium up on the periodic chart, you will see its atomic number 92, meaning it has 92 protons and 92 electrons. 92 plus 200, or 92 plus 143 is 235. And what I do want you to notice is if you look at uranium on the periodic chart, you will see that it has an atomic mass of 238, not the same number. So this is an example of where this particular isotope is not the most common isotope, and you cannot necessarily use the periodic chart to determine what the mass number is. It may be slightly different. This is actually the isotope that is used in atomic weapons. Now in this case we have the mass number and the number of neutrons. Well, because the protons plus neutrons equal the mass number, we can determine that if we have 7 neutrons, we must have 8 protons. And the atomic number would be 8. There would be 8 electrons, and this happens to be oxygen. So this is 15,7 oxygen. And of course, the last one, we're given most of the information. This should match up. Potassium is element number 19, 19 protons, 19 electrons when neutral. Mass number is 40, and it would therefore have 21 neutrons. But this is how you can use this information to get number of neutrons if you're interested, or to get the mass number. Again, here's your symbol. This is your atomic number. and this is your mass number, which is the number of protons plus the number of neutrons up here. And this is only the number of protons.